the next example, which says that prove that the radii of incircles of two similar triangles, the radii of their incircles are proportional to the sides of the triangle. What does it mean? Two triangles are similar, and in those similar triangles you can draw incircle, which you have done in the lower class. Okay, so the radii of the incircles are also proportional to the sides of the triangle. The practical meaning or the mathematical meaning is that the ratio of radii is equal to the ratio of sides of the triangle. So what is given? That these two triangles are similar. Now actually that we have to assume, but we write our assumption as given information. Suppose these two triangles are similar. Now you should know by construction of incircles that the center of the incircle is always the point of intersection of the angle bisector. So this is the incenter, that means point of intersection of the angle bisectors of the first triangle. In the same way, point S is the incenter of the second triangle, that is, it is the point of intersection of the angle bisectors. Okay, and from the center, when you drop the perpendicular on the side of the triangle, what you get is called as the radius of the incircle. So this is the radius of the incircle, this is also the radius of the incircle, and these radii are proportional to the sides. The ratio of radii is equal to the ratio of sides. This is what we have to prove. So the question I have explained. Now let us start with the proof. Okay. In triangle ABC and PQR, these triangles are similar. This is already given. Let me write given here. Now we know that if the triangles are similar, then corresponding angles are congruent. So angle B is congruent to angle Q. That means measures are equal. So I have written angle B is equal to angle Q. That means their measures are equal. So obviously half of angle B will be equal to half of angle Q. If the original angles are equal, then respective halves will also be equal. So half of angle B will be equal to half of angle Q. But what is half of angle B is this angle. And what is half of angle Q is this angle. Okay, that is what we have written. But half of angle B is DBE. Okay, DBE, and half of angle Q is SQT. Half of angle Q is equal to SQT. So in place of half angle B, I am going to write DBE, and in place of half angle Q, I am going to write SQT. Therefore, this equation 1 becomes DBE is equal to SQT. So what I have proven is that this angle is congruent to this angle. Exactly using the same logic, I can also prove that this angle is congruent to this angle. Now I don't have to write it again. We can write similarly angle DCE, this angle is congruent to angle SRT. Correct? We have given equation number 2 and 3 because later on we are going to use these two equations. Now, if I consider triangle DBE and triangle SQT, this angle is congruent to this angle, which we have already proven in equation 2. This angle and this angle, these two angles are congruent because when we talk about the radii of the incircles, these radii are always perpendicular to the sides of the triangle. So this is the radius of the incircle. This is also the radius. Therefore, these two angles will be automatically right angles. We have written both 90 degrees. So this angle is congruent to this angle. These two angles are congruent because both are right angles. Therefore, triangle DBE will be similar to SQT by A8S. We have written DBE is similar to SQT by A8S. Now, when you say that the triangles are similar, corresponding sides will be proportional. So DE upon ST, this ratio will be equal to dB upon SQ. Okay, the ratio of these two sides will be equal to the ratio of these two sides. Clear? Now we have written that dE upon ST is equal to dB upon SQ. Let me give this as equation number 4. Now I am considering triangle DBC and triangle SQR. DBC and triangle SQR. We have already proven that this angle is congruent to this angle. Also we have written that this angle is congruent to this angle. Again, two pairs of angles are congruent. So triangles will be similar by AA test. Which triangles? DBC and SQR. We have written DBC is similar to SQR. Two pairs of angles are congruent using 2 and 3. Here we have written that this angle is congruent to this angle is congruent to this angle. That is already mentioned in equation 2 and 3. So we are using equations 2 and 3 here to prove that these two triangles are similar. Now if these two triangles are similar, again we will say that corresponding sides are proportional. That means the ratio of dB and SQ will be equal to ratio of BC and QR. That is what I have written. dB upon SQ is equal to BC upon QR. Now what do I observe in equation 4 and in equation 5? This ratio is equal to circle and same ratio is repeated here. So that is a linking factor, and therefore I have shown a small arrow here. Okay, this ratio is equal to a circle ratio and circle ratio is equal to this ratio. That means DE upon ST is equal to BC upon QR. First ratio is equal to second and second is equal to third. So first is equal to third. This is called as transitivity. Therefore from 4 and 5 what we get? DE upon ST is equal to BC upon QR. Alright. Now these two triangles ABC and PQR, they are similar. So BC upon QR, this is the ratio of corresponding sides, that will be also equal to AB upon PQ, that will be equal to AC upon PR. That is what I have written. BC upon QR, this ratio of these two sides will be equal to ratio of these two sides will be equal to ratio of these two sides. Okay, so what you get? Again you get a link. This ratio is equal to this circle and this circle is repeated here. This ratio is equal to this circle and this circle is equal to these two ratios. That means all these four ratios are equal. That DE upon ST is equal to BC upon QR is equal to AB upon PQ is equal to AC upon PR. The only thing I have done that I wrote AB upon PQ first and BC upon QR in the middle, only because that is a pattern of writing. AB, BC, CR. Sorry, AB, BC, CA. PQ, QR, PR. Like that. So, what we have proven, this ratio is equal to this ratio is equal to these two ratios. That means all four ratios are equal. That is what I have written. But what is this? DE and ST, what are these two segments? These are the radii of incircles. So what I have proven, that the ratio of radii is equal to ratio of corresponding sides of the two similar triangles. That means, in other words, we can say that the radii of incircles are proportional to the sides of the similar triangles. Okay, so that proves the required result. Thank you, children.